So let's take a look at this. Casey and Marcus went to the movies and bought 2 bags of popcorn. Casey ate 4/5 of her bag, and Marcus ate 3/4 of his bag. Marcus ate more popcorn. Is this possible? Right? And I'm assuming they're asking us that question because 3/4 is smaller than 4/5. So it's almost like asking, well, how could Marcus have eaten more? Right? Especially when you consider that 3/4 is 4/5. Well, you have to take into account the size of the bag, right? If Casey has a 100-ounce bag and she ate 4/5 of her popcorn, then she ate 80 ounces of popcorn. However, right, Marcus could be eating from a 1,000-ounce bag. If Marcus is eating from a 1,000-ounce bag and he ate 3/4 of his bag, then he really ate 750 ounces of popcorn. So yes, it's very possible. It depends on the size of the bag, right? If we don't know the size of the bag, then we can assume that Casey ate more. But if we do have the size of the bag, then we can truly tell who ate more popcorn. So it all depends on the size of the bag of popcorns that they're eating from. Question B is saying with fraction strips represent one bag. With fraction strips to represent one bag, show how 4/5 is actually bigger than 3/4, right? So we can use our fraction strips like so. Here's one bag, right? Let me just make these a little even here, but you can see that 4/5 is actually a little bit bigger, right? This little distance here, it's actually a little bit bigger than 3/4. And you can do the same thing with your fraction strips that we made in class. So letter C, based on A to B or A and B, what do you think is really important to know in order to compare the fractions, right? What's really important is whether or not we're referring to the same whole or the same quantity, right? If they both ate from the same 100-ounce bag, then yes, right, Casey would have eaten more popcorn. But if we're not referring to the same exact bag, the same size, then we don't really know, right? It's important to know, and important to know this to know to compare the fractions. So are we talking about like 4/5 of 1,000 versus 3/5 of 3/4 of 2,000, for example, right? It's almost like saying, hey, if Q got he spent 4/5 of his allowance, and I'm gonna jot this down. Right, if Q spent 4/5 of his allowance and Molly spent 3/4 of her allowance, and then you ask the question, who spent more money, the first question that you would ask is what's their allowance, right? Because you don't really know who spent more money unless you know the size of the whole or the size of the quantity. So Molly could have a $10,000 allowance. I mean, yeah, that'd be amazing, but right, she could have a $10,000 allowance and Ku could only have a $1,000 allowance. So in that case, the 3/4 is actually more. Last but not least, right, page 58, order the following set of rational numbers from smallest to largest and justify each of the strategies you use. Do not use the common denominator strategy more than once. So we can use it, but we can only use it one time. So I'm looking at these, and I'm looking at 1/3, and I'm looking at 33%, and I'm looking at that because I know that 1/3 is equal to 33.33333%. So I already know that 1/3 is greater than 33%. Right? I also am looking at says they want us to justify each of the strategies, right? When I have a large set of fractions, the first thing I want to do is I want to see which fractions are greater than a half and which ones are less than a half. So I'm going to go ahead and use my benchmark strategy. And I'm using 1/2, right? I know that 1/3, I should put less than 1/2, more than 1/2. right? For less than a half, you know a third. 2/5 has to be less than a half because I know a half would be 2.5 fifths or 2.5 fifths. And then we know, right, we also know that 33% is less than a half because half would be 50%. We also just made the comparison about a minute ago that 33% is less, that 33% is less than 1/3. So if it's less than a third, then it also has to be less than a half. That means only two fractions are actually greater than 1/2. Right? 1/2 would be 4/8, but we have more than that. 1/2 would be 4.5 ninths, but we have 7 ninths. Cool. So we already established that 33% is smaller than 33.3333%. So we have to compare these two. And I'm looking at these two and I'm saying, well, I know that 1/3 is the same thing as 2/6. So I can compare 2/6 and 2/5 using common numerators. Why? Because the numerators are the same. So we look at the sizes and you know that 6 are smaller than 5ths. I want to make sure that I'm modeling the right thing for you guys. 1/6 is smaller than 1/5. Because if you cut up a PMU into 6 equal pieces, those pieces would be smaller than if you cut a BMU into 5 equal pieces. So we've got this part figured out, right? We know that 33%, then we got 1/3, because 1/3 is 2/6, and then we got 2/5. So now we just need to compare 7 ninths and 5/8. And guess what? I'm going to take my little lifeline here where they said I could use the common denominator strategy more than once. So I'm going to just use common denominators. And I get 56 over 72, right? And I get 45 over 72. So obviously 45 over 72 is smaller than 56 over 72. So that means next is 5/8. And last but not least is 7 ninths. Let me make sure that I write my strategy. Common denominator. Right? So I use benchmark to 1/2 to separate all the fractions that were greater n/or less than a half. Then I use common numerators to compare 1/3 and 2/5. And then I use common denominators to compare 5/8 and 7 ninths. Let me know if you have any questions. That's it for lesson 6.